Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is the procedural programming module. In the last class we have discussed about chapter number 16. In fact we have finished chapter number 16, that is your Windows programming base, that is your I think that is DOS based programming, Windows based programming, that is the chapter, that is C under the Windows. The name of the chapter is C under Windows. So we have finished that one, and in the today's class I'm going to start with your next chapter, that is chapter number 17, Windows programming. So let's take a quick review what we have covered in the last class, then continue with the session, that is continue with the chapter number 17, that is a Windows programming. In the last class we have started with this one. So let's take a quick review what we have covered in the last class. In the last class we have started with this one, that is how to start or how to do the Windows programming, that is a Windows programming a closer look, that is started with this one, that is a event driven model. So in simple terms, what is event driven model? That is whenever a user interact with the Windows program, there are so many events, or lots of event that occurs. So that is known as the event driven model. That means an event that occur, so the programmer has to choose some input and give the some basic outputs and provide some inputs. That means that is related to the input and the output. Suppose I am a user, I am inputting the command from the keyboard, I am getting the output. So that is a event driven model. That is on the basis of event, whenever an event occur, on the basis of that messages also predict or messages also occur. That is a event driven model. So this says whenever we call the function in the program, that is dictated by the order of occurrence of the events. That is one event occur, that is known as the, or this programming is known as the event driven programming model. That means whenever an event occur, whenever an order occur, that is known as the event driven programming model, right? Then we have discussed about the Windows programming a closer look. That means how to discuss the, or how, what is Windows programming a closer look. That means how it follows or how it works. That is also a next chapter, chapter number 17, but this is a closer look. We have discussed that messages are queued or processed in a FIFO order. First of all, this is the main thing. First of all, order is brought by putting all the messages that reach the application into a queue. That means first of all messages are coming up in the queue, that means in a line. Then messages in the queue are processed in FIFO. That means first of all a queue will be maintained, then it follows the approach, that is a FIFO, that is first in first out. That means the first element that is coming, that is the first element that is out, that is first in first out FIFO order. In fact, the OS also maintains several such queues, that is OS also, operating system also maintains the FIFO system. There is one queue which is common for all the application, that is queue is known as the system message queue. So there are various queues that is supported or that is available in the operating system. One of the queue is name is system message queue. In addition, there is one more queue for application, that is a application message queue. In simple terms, a queue that is common for all the application, that is known as system message queue, and the queue that is used separately by each application, that is known as the application message queue. This is the most important line. When we click with the mouse and an event occur, the device driver posts a message in the system message queue. This is the most important. So whenever we click with the mouse, we simply think that that will occur. No, in such a case an event occur, then it is the responsibility of the device driver. Suppose I am giving the input from the keyboard, so it is the responsibility of the keyboard driver to post the message into a system message queue or the system message line. The OS, that is operating system, retrieves such messages that have been sent. So it is the responsibility of the operating system to retrieve to which application this message has been sent. That means all the messages are cluttered in the system message queue. Now it is the role of the, or it is the responsibility of the operating system to allocate that messages into various applications. Next, it posts a message into an application message queue. That means the operating system also posts the message into the application message queue in which the mouse was clicked. So in simple terms, it is the responsibility of device driver to fabricate or to divide the messages into various parts, into various applications, that is application message queue. So this is the diagrammatical representation. These are the events. There is a keyboard, there is a mouse, there is a device drivers. There are messages that is delivered from the device driver. They are cluttered together in a system message queue. Right? Now, it is the responsibility of OS to divide such messages into various applications. Suppose there is a message that is sent for the notepad. So OS send this message to the notepad. Now there is a message that is for C++. So OS pick up the message from the system message queue and transfer to the Visual C++. So this is one application message queue, this is second application message queue, this is application 2, this is application 1. This is the main concept which you have to understand, because this is the concept that is going to continue with the chapter number 17. So this is most important. That is, first of all, device driver clutter the, or to get together the messages into a system message queue. Then it is the responsibility of operating system to divide such messages into various application, that is also or store the messages into various application, that is known as the application message queue. Right. Now then I think we have covered enough ground to be able to start C under the Windows. That is, we have created enough ground to start with the Windows. Now then we have discussed about the first Windows program, that is how it will be used. This is the header file for the Windows. This simple message is to display a hello message in the message box like this one. So this is the output. This is the coding in the Windows programming or the Windows chapter. So there are void main, like in our programs we are using the void main for main entry gate. In the same way, this is win main is used for the Windows programming, that is a Windows main. This is std call. These are the various arguments that we have discussed in detail in the last chapter, last class. Then there is a message box. This is a message box. There is a 0, hello, title, 0. This is the title, this is the hello. Let's talk about in brief, in quickly terms, because we have discussed in the last class. So this is the output. Now how, then we have discussed how this program will execute. In simple terms, we execute our program with the help of Turbo C, right? Simply uses the Alt F9, Control F9, and our program will be executed. But how the C or the C under Windows, that is how the Windows programming or Windows program will execute. So these are the various steps how one needs to carry to create and execute the program of the Windows. The first point says, first of all, start the VC++ from this one, this one, this one. Then window will be displayed. Then go to the file, click on the new, select this one, give the name, click on the OK. Again go to this one, click on the OK, and so on. You have to read by your own. Then Windows 32, step 1 will appear, that is a wizard will appear that will rotate from the step by step. Then select an empty project option and then click on the finish button. Then this will open, then close it by clicking on the OK button. Again go to the file, new C++ file, get the file name, click on the OK button. Type the program, the file will be opened in the VC++ IDE, that is Integrated Development Environment. Now save the file using save option from the file menu. Now this is the way how this program will cover up, that is how this program will save or how this program will compiled. Now how to execute? First of all, go to the build menu, click on the this one. Why this one? Because we have given the name as a sample one. Assume that no errors were reported in the program. Select execute sample 1 from the build menu. So first of all, uses the build menu, select on this one, then uses execute sample1.exe from the build menu. Now let us understand the concept, how it will use. Then we have discussed about the win main, that is what is win main, that is the entry point. This is the entry point for a Windows programming. Then what is the meaning of this one? These are the std call before this one that indicates the calling convention used by the win main. So this is the calling convention, how it will be called. That is a standard calling convention that contains two things. These are the two things. That means the order of the compilation, the order of the execution is from left to right or right to left, right? Then when a function has been removed, so this will be removed from the stack of at the end of the call. Out of the different calling conventions available, most commonly used conventions are CDECL and STD call. So this is the usage of this one over here. One more thing that is used, that is CDECL. Then we have discussed about this one, how another function that is used, this one. So if not mentioned, CDCL calling convention is assumed by the compiler. That is, either the program will execute with the help of std call. Otherwise, if nothing is mentioned, so this will, or calling mechanism is assumed by the compiler. Then we have discussed about this one. These are the arguments, or these are like a data types like H instance and the LPSTR or LPSTR, right? So these are the various unsigned pointers or pointer to the character that we have discussed. The H instance is the handle instance or instance handle, right? So win main receives 4 parameters. What are the 4 parameters? These are the 4 parameters: 1, 2, 3, 4, right? We have discussed about H instance, how to use the H instance, how or what is the usage of this one. Hello, yeah, are you able to hear me now? Hello, 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 yeah, are you able to hear me? Hello, 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 yeah, are you able to hear me, everyone? Okay. Then we have discussed about the H instance, that is what is the usage of the H instance, that is the instant handle for the running applications. So Windows create the ID number where the application starts, so it takes the instance. Then we have discussed then how it will handle. Yeah, it handle simply a 32-bit number that refers to an entity. The entity may be an application, window, icon, brush, cursor, bitmap, file, device, or any such entities. The actual value of the handle is unimportant to your program. So this is what we have discussed. What is the entity? But what is H instance? What is win main? What are the parameters that is used by the win main, like H instance, H previous instance, that is H pref instance, that is the next parameter. So this parameter is a remnant of the earlier versions of the Windows. That is how we are using, or how C program will use the earlier version, or how programs are executed in the earlier version. That is a H previous instant. It always contains a value 0, right? Then the next part is LPSJ CMD line. That is a pointer to a character string that contains the command line arguments. So this is the LPSJ CMD line, that is a command line. So this is the pointer to a character string that we are using whenever we use the pointer, whenever we use the Windows programming. That is a command line argument that is very similar to the ARGC ARGV that we have used in the DOS programming. That is a simple program that we are using. Then what is the use of NCMD show? That is an integer value that is passed to a function that tells the program whether the window that it creates should minimize icon, normal, maximize when it display for the first time. Then we have discussed about the message box. What is the use of message box? How it will return the 0 that indicates success, whereas non-zero indicates the failure. Instead of printing the hello in the message box, we can print the command line argument that the user may supply while executing the program. This is the example. Then LPSJCMD line, that is pointed to the string ABC IJK XYZ. That is this is the example of this one. If the entire command line including the file name is to be retrieved, we can use the get command line function. Then at last we have discussed about last topic of this chapter, that is a Hungarian notation. So whenever we have to give the variable name in a Windows programming, then we use the Hungarian notation. So this said, Hungarian notation is a variable naming convention called in the honor of legendary Microsoft programmer. That is, Hungarian notation is nothing but a variable naming convention. So whenever we use the Hungarian notation, that means we are using the variable naming convention, right? According to this convention, the variable name begins with the lowercase letters or letters that denotes the data type of the variable. For example, if I am using int a, that means int is the data type and a is a variable name. So in the same way, whenever we use the Windows programming, there is a concept that is known as the Hungarian notation that is used to identify or denote the data type. For example, SJ prefix in this one, SJ stands for string terminated by 0. So this is the prefix that is done by the Hungarian notation in the Windows programming. Then H in this one, that is hide or handle, not hide, handle. In the same way, N stands for the int, the prefix like LPSJ, that is long pointer to 0 terminated string. So that is provided by the Hungarian notation. Two more concepts are used, that is W param and the I param. Then we have discussed about the summary, what we have covered in this chapter. That is, it is a 4-byte long. There is a difference between the DOS programming and the Windows programming. Under Windows, a pointer is of 4 bytes long. Window programming involves a heavy usage of type-def. There are sequential programming models, whereas that means DOS uses a sequential programming model, whereas Windows uses a event-driven programming model. The main entry gate of the Windows program is the window main. So these are the various topics, these are the various points that we have discussed in this chapter. Windows does not provides or permit direct access to the memory. Windows uses a demand-based virtual memory model. Under Windows, this is, I think we have to discuss in detail because I think so many students miss some class. So I'm going to start with a point in detail. The first point says, under Windows, an integer is of 4 bytes long. That means whenever we use the Windows programming, the integer value takes the 4 byte. But if I compare with the DOS program that we have studied in the previous chapter, in that case the integer takes the 2 bytes. But under Windows programming, integer takes 4 bytes. That is, integer is of 4 bytes long. To use a 2-byte integer, pre-qualify it with short. That is, whenever we use whenever we use a 2-byte integer, then we pre-qualify it with a short. Suppose my requirement is only to store the gender, that is either male or female. So my requirement is a small int, that is a not of 4 bytes. So in such a case, we use simply as a short, that is a short int that takes only 2 bytes in the memory. The next point says, under Windows, a pointer is of 4 bytes long. This is a pointer, that means that stores the address that is of 4 bytes long. 4 bytes means 4 into 8, that is your 32 bits, right? Next point says, window programming involves a heavy usage of type-def. That is, whenever we use the window programming, it generally or it heavily use the type def in the concepts. Why type def? Because this is used to identify the type def or Windows programming. Then next point says disk operating system, that is DOS, uses a sequential programming model. That is, whenever we use the DOS that we have learned till now, that uses a sequential programming model, whereas the in Windows it uses a event driven programming model. So DOS is based on the sequential, that is from one part to another, another part to another, and so on. That is the sequential programming model, whereas whenever we use the Windows, everything is based on the event, that is a event driven programming model. Then next point says entry point of every Windows program. That is, when whatever we use, the entry point of the every Windows program is a function that is known as the winmain. So winmain is a function that is the entry point for the Windows programming. Like in DOS base we have used the main function. In the same way, there is a new function that is used in Windows programming, that is a winmain. Right. Then next point says Windows does not permit direct access to the memory or hardware devices. As I told you, Windows does not permit the direct access. Instead, it is or we are or Windows programs uses the device driver for the direct access for accessing to the memory. So Windows does not provide the direct access. Instead, it uses the device driver for accessing the memory or the hardware devices. Then next point says Windows uses a demand-based virtual memory model. So whenever we use the Windows programming, that uses a demand-based virtual memory. That is, whenever there is a demand, so we use the virtual memory. That means whenever a space is not sufficient in the main memory for storing the data, then in that case we use the virtual memory concept for the Windows programming. So it uses a demand-based virtual memory model to manage the memory. The next point says under Windows there is two-way communication. Two-way communication means at both the end, that is, we also one user also communicate with another user also communicate with another. So Windows provides a two-way communication between the program and the OS. That is, something is provided by the program to the operating system and something is given by the or supplied by the operating system to the program. Right. Then next point says Windows maintain a system message queue that is common for all the applications. That is, Windows offers or maintains a system message queue. As I told you in the today's session only, that every program that is stored in Windows that maintains a queue that is known as the system message queue, that is common for each and every application, that is common for all the applications. Then next point says calling convention decides the order, sorry, the J point is left. Windows maintain an application message queue per running application. In the same way, as there is a system message queue, in the same way there is an application message queue that is for each and every application, that is per running application. Then next point says calling convention decides the order in which the parameters are passed to a function and whether the calling function are or the called function clear the stack. So it depends on the calling convention that decides the parameter. That is, whenever we call the function, it decides the parameter, what type of parameters we need. We need H instance, we need H previous instance, and so on. Then L point says commonly used calling conventions are CDECL and the STD call. So if nothing is mentioned, we assume that it is CDECL. But if it is mentioned STD call, that is a standard call. Last point says Hungarian notation, though good, its usage is not recommended anymore. That is a variable naming convention, but we are not using this one sorry, due to the programming errors. Then we have discussed about the question answers. I think one or two questions then we have discussed. Then these are the various theoretical questions, program based questions. So now let's start with chapter number 17. I'm just coming within 2 minutes. Now let's start with chapter number 17, that is Windows programming. Till now we have made a base in the chapter number 16, that is C under Windows, that is what is Windows programming, why we are using the Windows programming. Now let's take in detail what is a Windows programming, right? This chapter contains various topics like the role of a message box, why we are using the message box. Then here comes the Windows, then more Windows, that is what is the advantage, why we are using the Windows. Then a real world window, that is how to create and display the window, that is how to do the programming in the Windows. Then interaction with the window, reacting to the messages, then program instances, summary exercises, right? So let's start with the chapter, introduction of the chapter, that is what is Windows programming, right? Now, this says event-driven programming requires a change in mindset. That is, whenever we use the Windows that is based on the event-driven program, that is a event-driven programming, that is a Windows programming. That requires a change in the mindset, that is a change in the mindset of the programmers. I hope chapter number 16 has been able to bring out this change. That is, we have, as I told you, we have made the base from the previous chapter, that is able to bring the change. However, this change would be bolstered by writing the event-driven program. That is this change, that means which change, that is a change that is from converting the DOS base to the Windows base, that is the event-driven programming. That is, or this is what this chapter intend to. That is, this is the chapter what is intend to do. That is how to convert the DOS base, that is a sequential model, or that is sequential programming is converted into the event-driven model. This is what this chapter intend to. Right. I am hopeful that by the time you reach the end of this chapter, you will be more comfortable with it as you have been using it all your life. That is, this is just a line that shows that this is very easy chapter and you are able to cope up each and everything within this chapter. Now, what is the role of a message box? This is the question, or this is the topic. That the role of a message box. Why we are using the message box? So, I think you can also answer from the last chapter. What is the role of the message box? Don't worry, I will answer. The role of a message box, or generally usage of the message box, is to display on the screen. In simple terms, whenever I want to display something on the screen, that is done by the message box. So this is also a role of the message box, right? So this says often we are required to display certain results on the screen during the course of execution of the program. As we use in normal DOS programming, printf, for the printing purpose. So it is also, this says it is required to display the certain results or the common results on the screen during the course of execution of the program. We do this to ascertain whether we are getting the results as per our expectations or not. That is, we are able to challenge, or we are able to see whether we are executing the programs correctly or not by getting the results on the screen. And that results is provided by the message box under the programming, under the Windows programming. So this says in a sequential DOS based program that we have studied, or that we are studying right now also with the help of the programs, that is a sequential DOS based programs, we can easily achieve using the printf statement. As I told you, under Windows, screen is a shared resource. That means we are using the printf in the DOS based, but in Windows we are using the message box or the message for creating the applications or for the sharing the output. So you can imagine what chaos would it create if all the running applications are permitted to write to the screen. That is, imagine what is the output, what chaos would you create, or what would it create if each and every applications are permitted to write to the screen. You would not be able to make out of which output is what of application. That is, it is very hodgepodge whenever there are multiple display on the screen. So how do you think or how do you judge what is the output of which application? So this says there is a hodgepodge condition, there is a chaos, and we are not able to differentiate of which application it will display or what is the output of what application, right? Hence, no window program is permitted to write anything directly to the screen. That is, window programming does not provide to simply write on the screen with the help of the printf. Like we are using the printf to simply print on the screen, but that facility is not provided by the message box under the Windows. That is where a message box enter the scene. That is that's the main reason why we are using the message box under the Windows programming. Using it means using message box we can display intermediate results during the course of execution of a program. That is, whenever we use the message box we can display intermediate results or the immediate or the in between results during the course of the execution of a program. That is, whenever we execute a program, so it can display the intermediate result for the execution of the program. It can be dismissed either by clicking close button in its title bar. That is, we can close it or we can close the message box by simply clicking the OK button that is present in it, or simply the close button that is available in the title bar, or simply clicking the OK button that is present in it. So we can either close the button, we can either put the on the cross sign, or we can either click the OK button that is present in it. There are numerous variations. There are so many variations. There are so many conditions, rules, regulations that you can try with the help of the message box. Some of the examples are given below. That is, some of the examples are given over here. Now, first is this one. There is a 0. Are you sure, Captain? MB, yes or no. This is the first one. Next one. 0. Print to the printer. Caption. MB, yes, no, cancel. Message box. 0. Icon is all about style. Caption. MB, okay. MB. Icon information. Right. You can put the above statements. Above statement means either you can put one, two, or three of them within the win main. So win main is the main function. You can put the above statement, that is a message box statement, within the win main and see the result for yourself. Though the above messages give you a flexibility in resulting and displaying the results button icon, there is a limit to which you can stretch them. That is, there is a limit to what extent you can stretch, you can provide the input, you can display the output on the screen. What if we want to draw a freehand drawing or display an image etc in the message box? That is, the windmain or the message box also provides a facility to draw a freehand image to display use a freehand drawing to display an image on the message box. This would not be possible. To achieve this, we need to create a full-fledged window. The next section discuss how this can be done. That is, whenever there is a requirement to draw a freehand drawing or display an image in the message box, that is not possible in the Windows programming. To achieve this, we need to create a full-fledged Windows. The next section, this is the next section that is discussed how we are using the Windows programming, how the message box display on the screen. So this is the next chapter is here comes the window. That is here, this is the window that is comes. So before we proceed with the actual creation of a window, it would be good idea to identify various elements of it. That is, we are now trying to get each and every element, that is, we are able to get the each and identify the various elements that is used in the Windows that are shown in this chapter on this figure. So first one is a caption bar, that is also a title bar or the caption bar. There is the icon. This is the icon that is of hello. This is the title bar, that is a caption bar. Then this is the minimize box, this is the minimize box, this is the maximize box, this is the close button, right? These are the various menus, like AA, BB, CC are the menus. So this is one menu, this is one menu, this is one menu, right? This is the vertical scroll bar or vertical scroll. This is the L is missing. This is the vertical scroll. This is the horizontal scroll. Means we can move from this to this, from left to right and right to left. And from top to bottom and bottom to top, we are using with the help of the vertical scroll. Then horizontal scroll. This is the client area, means in which we have to write something, that is known as the client area, right? So this is, one is a caption bar, one is a minimize box, close button, vertical scroll, horizontal scroll, client area, that is a window area in which we have to write something. These are the menu, this is the icon. This is the various elements of a message box. Note that every window drawn on the screen need not necessarily have every element shown in the above figure. That is, it is not mandatory that each and every element is showing each and every time whenever we display on the screen. No, this is not compulsion. We can use any one of the option. We can use either icon, client, menu, anything that I need for the window. For example, a window may not contain the minimize box. This is the example. May not contain the maximize box, the scroll bar, menu. These are the various examples. Let us now create a simple program that creates a window on the screen. So let us start with the one basic program. This is hash include window.h. This is the header file that is used. Now this is the main concept. This is the program. Uses the int std call win main, right? That is a int take the integer value std call. This is, as I told you, the compiler is taking care of this. That is a standard call. This is the calling mechanism. Then there is a win main. Win main is like a main gate of DOS programming model. Whenever we use the simple main, and this is win main, that is a main gate for the Windows programming. Now there are various parameters, there are various arguments that is using after the bracket, that is h instance, that is h instance is like a type definition, and this h instance is like a variable name. Then again h instance, h previous instance, then lpstr, lpsj, cmd line, then int and cmd show, that is an integer value, that is a discrete value, right? Then uses the hwndh. This is the variable. Now this variable stores the output of this one. So the output of this one will be stored or will be displaying on the h, right? So this is create window. That means creating the window over here. That is a create window. There is a button. One button is created. That is a press hit me. Then ws. This is not hit me. This is basically press me. Right? This is wrong. This is press me. So this is press me, not hit me. Right? Then ws overlapped window. That is overlapped window means one over the another window. This is overlapping. Then these are the various centimeters, various measurement. This is of size 10, 10, 150, 150, 100, 0, 0, I0. Right? Then this is the show window. That is a show window option is used. Show window function is used. That contains two arguments. One is h, one is ncmd show. Right? Then uses another message box, that is for this one. So this is overlap. This is just example. I'm discussing in detail after this one. So this is show window. This is the message box. Now this is high. This is what is covered in this one. That is the high. So this is press me, not hit me, right? Then there is a waiting. This is the name of the waiting, right? Waiting. Then MB OK. This is the button that is used, that is the OK button. Then there is a return 0. So these are the various content that is available. One is HWND, there is a variable H. Then H is used to store the data, that is a create window is the function. These are the various parameters that is used, that is creating a window that is overlapped on various sizes, and the content is press me. Then show window, HND and NCMD show. Then message box are for another window. So this is for one window, this is for another window, right? This is the return 0, this is the output of the program. There is a press me and there is a OK. Now let us understand the program, but I will continue this session after, or maybe in the Monday's class. Why? The main reason is that right now I'm going to take a break. After the break, we will discuss the practical approach of the simple sequential programming, that is a DOS-based programming. So if the time is left or the time permits, then we will continue with this one in the today's class. Either we will continue in the next class. So let's take a break right now, then continue with the practical approach. So let's take a break. So come back from the break. Let's start with the practical approach, or let's start with the session. So let's take a practical approach on the programs, or that is running the programs, executing the programs. In the last class we have discussed, not in the last class, in the last class we have not discussed any program because you are enjoying the Christmas, so I will not discuss. So in the last to last class we have covered one program that is used to display the asterisks. There are various asterisks in various lines. In one line there is one asterisk, another line there is two asterisks, three asterisks, four asterisks, right? So there are lines that is entered by the user, and there are so many asterisks that is used. So I'm going to continue with the same, not with the asterisk, but with the sequence or the series of the numbers, like 1, 1, 2, 3, 1, 2, 3, 4, and so on. The same pattern, a rectangle is made, pyramid is made, but using the not asterisk, but using the series of the numbers, like 1, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and so on, right? So I'm going to start with the program. So first of all, the same header files will be attached, that is the hash include stdio.h. Then the next file is header file is hash includes conio.h. Then uses the void main, then uses the curly braces. Then I'm going to start with declaring the variables, that int I, j, k, for example. Not k, I'm using this one, x, for example. Then uses the printf for displaying in the on the screen, that is the enter the value of x. Right. Then scanning the this one, that is using the scanf. Then uses the percentage d. Then uses the ampersand d or x. Right. Then clr scr for clearing the screen. Here this I have to use in the this not here, after declaring the variables over here, clr scr. Right. Now I have to use two for loops. One is for the row, one is for the next line, one is for the outer loop, one is known as the inner loop. For example, I am using j equals to 1, or I anything. Then j is less than equals to x, that is the x that is provided by the user, that is the value, or enter the value of x, that is how many lines you are printing or you are able to print, right? Then there is a j plus plus. Then I'm using next for loop, that is a inner for loop. again but in this I am using I equals to 1. Then condition is I is less than equals to j, then I plus plus, right. Then uses printf percentage d, then uses I for printing on the I, then uses the next line, that is for printing in the next line. This for loop will be closed over here, then uses the printf for printing in the next line, that is a backward slash n. Then close this one, close this one, then uses the get ch for printing on the screen, then uses this one. Now if I compile this code, there is a success, yes. If I execute this code, enter the value of x, yeah, this is the right answer. Suppose I have entered the value of x as a 4, so this will be printed like 1 1 2 1 2 3 1 2 3 4. So this will be printed like this one in a sequence in a different row. So this is the program. Here I have declared the header files, that is stdio.h, that is a standard input output, conio.h, that is a common input output, right. Then I have started with the void main, that is a void main function. This is the curly braces, then int ijx. So these are the three variables that is declared, that is ij and x. Then uses the clear screen for clearing on the screen. That uses the printf, that is enter the value of x, that is enter the value of x that is given by the user, then store in the memory or storage into the memory by using the ampersand, that means scanf percentage d. Why I am using percentage d? Because it is of integer type. Then ampersand x, then uses two for loop, one is the inner for loop, one is the outer for loop. So one is for j equals to 1, that is the first. Then condition is that it will execute until it is less than x, then j plus plus. Then next one is I equals to 1, I is less than j, I plus plus. Then prints the value of I. Go to the next line, again prints the value of I. Go to the next line, prints the value of I. Now let's dry run the program, that how it will execute, that is a dry run. So first of all, here suppose as per my example, as per this example, the value of x is 4, right. So here user has given the value 4, so this is 4. Now j is equals to 1, that is 1. Now check the condition, 1 is less than equals to 4, condition is true, that is 1 is less than 4. Then go to the inner loop. Now check the condition, first of all I is 1, I is less than equals to j. Here j is 1 right now, 1 is less than equals to 2, 1 is less than equals to 1, condition is true. Then prints the I value. What is I value? That is a 1. So 1 will be printed. Now moves to this one, again cursor moves over here, this for loop. Now the I becomes 2. Why? Because this is I plus plus, I becomes 2. This is the condition. 2 is less than equals to j. J is right now only 1, because j is not incremented, because we are only in the inner loop right now. So this is 1, 1 is less than equals to 2, condition is false. So this row will terminate. In the first line only 1 will be printed. Now go to this statement, moves to the next line, go to this one, cursor moves to this one on the outer loop, that is j equals to 2. Now j becomes 2. Why? Because this is j plus plus. Now j becomes 2. This is 2 is less than equals to, this is 4, this is 2 is less than equals to 4, condition is true, 2 is less than the 4. Then go to this one, that is I equals to 1, I is less than j, I plus plus. Now this is 1, because this is last time this is vanished, this is finished, so again it is starting. This is 1. So check the condition. 1 is less than equals to 2. This time j is 2. Yeah, condition is true. 1 is less than equals to 2. Then prints the value of I. Now the I value is 1. Right. Now go to this one. Again go to this one. Inner loop. Now I becomes 2. Right. This is I plus plus. Now check the condition. 2 is less than equals to 2. Why? Because j becomes the, or j remains the 2, because that is of outer loop. 2 is less than equals to 2. 2 is equals to 2. Condition is true. Go to this one. Prints the value of I. Now the I value has a 2 value. So there are two numbers that is printed, that is 1 and the 2. Moves to this one. Again moves to this part. Now I becomes 3. 3 is less than equals to 2. Condition is false. Then moves to this one. Then moves to this one. Go to this one. Go to first part. Now j becomes 3. Why? Because this is j plus plus. Now check the condition. 3 is less than equals to 4. Condition is true. Moves to inner loop. Now I is 1. Check the condition. 1 is less than equals to 3. Yes, condition is true. Prints the value of 1. Again go to this one. Now I becomes 2. 2 is less than equals to 3 because j value is 3. Condition is true. Print the value of 2. Again moves to this one. I's value is 3 because this is I plus plus. This has a value 3. So this is 3 is less than equals to 3. Yeah, it is equals to. So condition is true. Prints the value of 3. Now I becomes 4. 4 is less than equals to 3. Condition is false. So moves to this one, that is loop will terminate. Moves to this one. Again moves to this one, outer loop. Now j becomes 4. 4 is less than equals to 4. Condition is true because this is equals to 4. Moves to this part. Now I has a value 1. So check the condition. 1 is less than equals to 4 because right now j has a value 4. Condition is true. 1 is less than 4. The I will be printed, that is 1. Again go to this one. Now I becomes 2. 2 is less than equals to 4. Condition is true. Then this will be printed, that is a 2. Now I becomes 3. That is 3 is less than equals to 4. Condition is true. Next will be printed, that is 3. Now I is 4. The condition is true. 4 is less than equals to 4. The 4 will be printed. Now I becomes 5. This 5 is less than equals to 4. Condition is false. So this will terminate and moves to the this line. Now jump to next line. Now go to over here. Go to the outer loop. Now j becomes 5. Check the condition. 5 is less than equals to 4. Condition is false. Why false? Because 5 is not less than, but 5 is greater than the 4. So condition is false. So this will terminate and move to the outer loop, or exit from the loop, exit from the program. So the output will be displayed. In the first line there is a 1. In the second line there is 1 2. Third line 1 2 3. Fourth line 1 2 3 4. So 4 lines the output will be printed. So this is the way how it will execute. Now I am again executing this code. Suppose I have entered 6. Now this is the same 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5 1 2 3 4 5 6. So this is in multiple lines it will be printed. In the first line there is only 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers and 6 numbers. Suppose I have to give some space over here. So this is the space, or this is the colon, and there is some space. Or suppose I have to give one space, then I have to use T, that is a tab. Now if I execute this code, yeah, there is a space. If I use this one, this will be the output. Now I save this program. This is the series. Right. Now any doubt in this program? Anyone any doubt in this program that I have executed about a series of number? Yes. You didn't understand the concept. You were present in the last class when we discuss about the asterisk. In the last to last class when we discuss about the asterisk, that is a star program. Okay, you were not present in that class. Okay, that's the main problem. I'm repeating this program again. And first of all, I'm going to continue, or I'm going to display with the program, that is what is the usage of the two loops, that is the outer loop and the inner loop, right? So first of all, my target is to get the input from the user, right, and display in the multiple lines. Okay, so first of all, take the input from the user, scan in the memory. In simple terms, I have to display the series. For example, like this. If I press 2, in the two lines the output will be displayed. In the first line it is 1, in the next line it is 1 2. Right. This is my concern. This is my target. So I'm using, yes. Hello. Yeah, yeah, sure. Tell me. Mm, just to yeah, just to yeah, yeah, hear me. Just to tell you that how the series will be printed, how we are able to print in a rectangle, in a square, in a pyramid. That's the main concern. Or just this is just showing the outer and the inner loop. This is just showing till the inner loop will terminate, then we can move to the outer loop. That means until and unless inner loop will not terminate, we cannot move to the outer loop. So that is the main advantage of showing this program, just to show what is the usage of inner loop, what is the usage of outer loop, how the pyramid will be printed, how we can print in a rectangle form, triangle form. That is the main concern. So this is right. This is in a triangle form. That is a upper triangle, right? So this is just show. For example, if I compile this in a this way, uh, like this one. Suppose I have printed in this. So this forms one triangle. So this is just showing a sequence or series in a triangle, in a pyramid, in a rectangle, and nothing else. This is just a program of using the for loops. You understand the concept, how it will move to this one, this part, how will it move to this loop, when this condition is false, move to this one. This is the main concern. Okay, so let's start with the basic concept, right? So if I compile this code, my target is to print in the two lines, like 1 and the 1 2, right? Suppose that means 2 is given by the user, right? Now going to this one, first of all, for loop. The first one is j equals to 1. That means j has a value 1. We initialize the j with the 1. These are the variables. We initialize the j with the 1. Now check the condition. J is less than equals to x. Now x has a value 2, that is supplied by the user. Check the condition. 1 is less than equals to 2. Yeah, that's true. 1 is smaller than the 2. If this is true, condition is true, then only we move to the inner loop, right? Now I has a value, this is initialization, I has a value 1. Now this is the condition, this is based on the j has a value right now 1. 1 is less than equals to 1, this is equals to, so the condition is true, right? If on then only we can move to the inner part. That means now this is printf percentage d I has a value. Yeah, yeah, sure. Hmm. I Yeah, yeah. But you see, inner loop is related to the outer loop. Yes. And the main condition is that when the inner loop terminates, then only moves to the outer loop. That means if the inner loop will execute for the 5 times, then we can jump to the inner loop only. That means in simple terms, there are two boxes, one inside the another. The inner box will remove first, then only we move to the outer box. In the same way, the inner loop will terminate first of all. uh, Terminate means the condition will falls of the inner loop, then only we move to the outer loop. And inner loop is related to the outer loop in just this way. This is the condition on the basis of the outer loop. Now you understand something. J j equals to 1. Why? Because this is a 1. This is related to this one. J has a value 1. This is the outer loop. Hmm. Yes. Yes. Hmm. It has it has incremented afterwards. It is not incremented right now. First of all, this will be printed. Then only it will increment. Yes, 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 yes. Yeah, right. Mm-hmm. Yeah. Yes, yes, yes. That's why both the loops are related with each other. But the main concern is that you have to take this or dry run this program at least 5 to 6 times. Then only your concept is clear, because this is for the first time, right? So you have to understand the concept, dry run the program at least 5 to 6 times by your own, not with the help of the teacher, not with the help of anyone, by your own. Then only you get the point. What is the usage of inner loop? How it will execute? The what is the value of this one, that one, and so on. So at least try it for the 5 to 6 times. Okay. So can I continue with the practical approach, or can I stop this class right now? Continue with the class, or right now stop it? Okay, so let's continue with one more program. Okay, 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 sure. Now let's take one more program, like similar program. Okay, can I tell you the asterisk program? That is how many stars you have printed, or what is how the stars will be printed. So let's start with the program of stars will be printed. I think that program is over here only. I have to open. This is the star. This is the stars, right? Now, understand the concept. Are you able to hear me, Olesam? Hello? Yeah, this is this is the similar program. The output of this program is like this. First of all, I will show you the output. Mm, yes, yeah, like this one. This the same. that it is represented in a triangle form, but the asterisk is there, not the series 1 2 not, but the similar value, that is a star, right? So this is the program. Now let's see what is the program. First of all, there is the same header files, there is a void main. There are two variables or three variables that is declared, x, I and j, right? There is a clear screen, then uses the printf statement for printing on the screen. That is how many lines the star will be printed. That is how many lines you want the star will be printed. That is if you think that the star will be printed in a 4 lines, then the x value as a 4. If you think the star will be printed in a 5 lines, then the then the x will be 5, right? That uses the for loop. That is the first outer loop, uses the condition, that is I equals to 1, I is less than equals to x, I plus plus, right? Now first of all uses the this one, I has a value 1. Now suppose I've given the x as a value 4, that means I want the star to be printed in the 4 lines, right? Now check the condition, 1 is less than equals to 4, condition is true, then only moves to this one. Now j value has a 1 right now. Now check the condition with the I, 1 is less than equals to, because j has a value 1 but I has a value 1, 1 is less than equals to 1, it is equals to, condition is true, then the star will be printed. That is in the first line 1 star will be printed. Why? Because the condition is true. When this star will be printed, then moves to this one. When we move to this one, then automatically, this is the closing brace, automatically it moves to the inner loop only. Why? Because inner loop will not terminate it right now. We have not checked that it may be terminated, it may not be terminated. Now check the condition. Now j value becomes 2 because this is j plus plus. J has a value 2. Now check the condition. 2 is less than equals to 1. I has a value 1 because we have not moved to this one. We have moved to only this one. So I value has a same value, that is a 1. Check the condition. J is less than equals to I. That means 1 is less than equals to 1. Condition, sorry. J, and right now j has a value 2 because this is the second time. Check the condition. 2 is less than equals to 1. Condition is false. So whenever the condition is false, then moves to this one, that is outer of this one. Moves to this one, that means in the next line, moves to this one, then moves to the outer loop. Now I has a value 2. Now I value becomes 2. Why? Because this is the second time. This is I plus plus. So I value becomes the 2. Now check the condition. 2 is less than equal to 4. Why? Because x value, that is the lines value, have the same output, that is a 4. So check the condition. 2 is less than equals to 4. Condition is true because 2 is less than the 4. Then moves to the inner loop. J has a value 1. J is less than equals to I. Now I has a value 2. J has a value 1. 1 is less than equals to 2. Condition is true. Then print the star. 1 star only. Then moves to this one. Again moves to this one. Now j has a value 2. Check the condition. 2 is less than equals to 1. I has a value 2, not the 1. So 2 is less than equals to 2. Condition is true. Why? 2 is equals to 2. So the one more star will be printed, right? Then moves to this one. Again moves to this one. Now j has a value 3. Now check the condition. 3 is less than equals to 2 because I has a value 2. So 3 is less than equals to 2. Condition is false because 3 is not less than. 3 is more than equals to 2. Condition is false. Whenever the condition is false, bring out from the loop, moves to this one, again moves to this one. So in the second line, 2 star will be printed. In the same way, now I has a value 3. Check the condition, moves to this one, so on, so on, so on. The 4 times it will be printed. So the output will be like this one. 1 star, 2 star, 3 star, 4 star. Why? Because we have given the input as a 4. So here the input given is the 4. So in the 4 line the star will be printed. In the first line there will be 1 star, second line 2 stars, third line 3 stars, fourth line 4 stars. Suppose I've given, or I will give the value as a 6. So in the first line 1 star, 2 star, 3 star, 4 star, 5 star and 6 stars. So this is the way how we are able to print in a triangle form, in a pyramid form. This is the way. Olesam, are you able to get little bit, not exact, but little bit? But please focus on this program. Try to dry run this program at least 5 to 6 times. Then only your concept is clear. All right. So let's stop. Yeah, let's stop the class over here only. Oh, and how was your Christmas? Okay. Okay, good. India. Okay. All right. So okay, and the next class I will continue with the practical approach. What happened? What happened? I will continue with the practical approach as well as the explanation of this program. Right. So let's talk. Yes, yes. Tell me. Yes. You want to see the Windows programming output? Ye- Yeah, I will start after one or two class. Okay. So thanks a lot for listening me. And in the tomorrow's Monday's class, I will continue with the explanation of this program as well as the practical approach. Okay. So that's all. Bye bye. Welcome. Okay. Same to you. Bye bye.